ask you, what is 1 to the power of any number? For example, if I raise 1 to a very large number, as you can see on the screen, what is the answer to that? A 1, right? Now let me ask you, if we are raising any small or big number to the power of 0, what is the answer? A 1? Well, isn't this a very simple logic to apply? This is the kind of logic that we will need for today's properties in logarithms. So let's go ahead and dive straight in. I'll see you around. All right, let's get started. As you can see on the screen, I have already written the definition of the logarithm, both as a log and an exponent. Now, before we begin, there are two essential conditions that we need to understand about the number a to which we're finding the logarithm and the base number b. Now, what are they? First and foremost, easy condition that both of them have to be positive. Now, for the number a, for example, let's say if you were trying to figure out if it was log to any number base, but you wanted to figure out an answer to this question, that basically what exponent are we raising this base number b to get 0 as an answer, you know? So that kind of a condition does not exist. Now, please do not get confused. The answer to a logarithm can be a 0 or a negative number. For example, we can have log to the base 4 or 1 over 4 is going to give us an answer of negative. The answer can be negative, but when we try to figure out the logarithm of a number, that number a has to be a positive number. Now, that might just flirt with the idea a little bit until you get comfortable. It is a little bit of a challenge, okay? Then let's talk about the base. The base again has to be a positive number and not equal to 1. Think about it. We are raising minus 1 in this example right here to some number x to get an answer a. Now let's say to actually, what number are we raising this number to? Minus 1 to squared, minus 1 to 4, what? We don't know, right? So it's going to be not valid. Same way, the base number cannot be equal to 1. Why? Because if the base were a 1, let's say this was 1, and you have a 10 here, what is the answer? Basically, 1 raised to any number is going to give you an answer of 1. So once again, that is going to be undefined. So the two important conditions to solve any logarithmic problem is going to be that the a number has to be a positive number, and same way b has to be a positive number. All right, with that information in hand, let's continue with the properties. Okay, the first property, as you can see on the screen, is written, and it's pretty much very straightforward. Let's take an example here. So log, let's say, to the base 6 of 1 is what? So basically, what are we asking? Let's say this question mark is x. Basically, the question is asking to what number shall we raise the base number 6 to get an answer of 1. The only answer or possibility is for x to be equal to 0, which will give you an answer of 1. So this property here is again using just common logic that any number raised to the power of 0 will give you a 1 as an answer. And this can also be log to the base of 250 and answer will still be 0. Remember, the base cannot be negative either. Next property, log to the base b of the number b. So how we understand that? Let's say log to the base 5 of the number 5 is question mark, and if this question mark is x, what is it? So basically, again, we are being asked to what number shall we raise the base number to get the same number. The only possible and logical answer is x should be equal to 1, meaning this number should be raised to the power of 1 to get b. And that's the idea here. So again, once again, as you can see, this is nothing but common logic. Now, next property is, now as you can see, we have the same base and the number, but the number is raised to the exponent of k. Now, if you will recollect from the top 3 properties that we did in one of the previous videos, it is going to be log, let's take an example. I'll take 6 and let's say it's raised to the power of squared, and answer should be 2. So now we are utilizing 2 properties here. Remember, Logarithms also, like any other topic or concept in mathematics, combines the properties. So it's a very common thing, and that's usually what you find. So we have, we will take the 2 here, 2 log 6, and this should be equal to, we already learned just now, 6, the answer to this is going to be 6. To what number will give you a 6? The answer is going to be 1. So this reduces to 1, and 2 times 1 is a 2. So there we go. That's the answer. So when you have the same base and the number to which you're finding the logarithm, but that number is raised to some kind of an exponent, the answer is going to be an exponent. Moving on further, on the next property, what we have is any number b is raised to the power. That means on the exponent we have a logarithm. So let's take an example. Let's say we have 7, but this has an exponent that is raised to the power of an exponent. That is, we have a logarithm in the exponent, but provided, please note, this number b and the base of this logarithm, which is in the exponent, are the same, then we are saying the answer should be 49. Let's test it. So I'm going to rewrite this: 7 raised to the power of log to the base 7 of 49. So first and foremost, we want to take care of the exponent. Simplify that first. So we know by the basic definition of logarithm, this is going to be 7 to what number is going to give us 49, which is going to be 2. So the answer to this is going to be 2. So what are we left with? 7 squared, which is nothing but 49, meaning 7 times 7. And that's exactly what it is here. All right. Okay, so simple property. Now, the most important property which we frequently utilize in calculations is a change of base. Now, you will notice, bring your calculators and take a look. There are 2 log buttons that you see. One that has written just log on it, and the one that has ln standing for natural log. The one number, the button that you're talking about is log, which represents, in my previous video on properties, I told you when we write the word log or we write log to the base 10, they are basically equivalent, meaning we are referring to the base 10. So your calculator actually only has the possibility to calculate any logarithm in base 10. Now, what if we have a question like this to some other base where the base number is 6? That's where we utilize the change of base and we utilize a change of base property. Okay, let's see how this works out. Log to the base b of any number a, and you will, if you want to utilize a change of base, you can pick any number for this base number. Remember, it has to be a positive number and not equal to 1. So between 2 and 9, you can pick any number for the base. Sorry, 2 and 10, you can pick any number for the base and just substitute that here in this equation. So log to the new base c for the a divided by log to the new base c divided by the old base. Now let's take this as an example. For example, we have log to the base 6 of 216. So our answer should be 3. Why? Because we know that 6 raised to what number will give us 216? It is going to be 6 cubed. So answer to this equation is going to be 3, right? Let's test the change of base. So in the change of base, I'm going to choose the base 10, okay? Why? Because it's easy to, that's the number, that's the button for which the calculator is programmed. So always change it, advisable to change it to another, unless there's a specific type of a question. So log to the base 10 of 216 divided by log to the base 10 of the base 6. Now, if you bring in your calculators and we key in the values, this value turns out to be 2.3344, and the value in the denominator turns out to be 0.77815, which approximately reduces to 3. And it is exactly the same answer that we were expecting here. So you can test it out with multiple numbers that you want and try all of these properties on your own. Once again, do let me know if you would want me to solve some complex problems or just need some help, want me to conduct some sessions for you. Please feel free to connect with me, and my information as always has been provided. All right, I'll see you around for the next presentation and any topic that you will have to suggest for me. Thank you so much. Bye-bye.